As the calendar flips to September 18th, 2025, this cosmic intruder, designated 3I/Atlas, aligns perfectly with humanity's latest revelations about potential life beyond Earth. Just weeks ago, NASA unveiled groundbreaking data from the Cassini mission's legacy archives, reanalyzed with cutting-edge tools, suggesting that the hazy atmosphere of Titan and the icy plumes of Enceladus might harbor the building blocks of primitive life, organic molecules dancing in alien lakes and subsurface oceans, whispering possibilities of cells forming in the cold embrace of Saturn's moons. But why now? Why does this visitor arrive precisely when our telescopes and probes are peeling back the secrets of these distant realms, as if the universe itself is orchestrating a grand reveal? This isn't just a flyby. It's a convergence that feels almost deliberate, a puzzle piece snapping into place in the vast mosaic of the cosmos, leaving astronomers breathless and dreamers like us pondering the impossible. As I guide you through this tale tonight, nestled in the quiet of your own space, I can't help but wonder where you are right now, perhaps curled up under a starry sky, in a quiet town, or drifting off in a bustling city apartment as the world outside fades. If this story captivates you as much as it does me, why not hit that like button to let the algorithms know we're onto something profound? Subscribe for more journeys into the unknown, and drop a comment below like a digital postcard, sharing your location and the exact time you're listening. It's like sending a message across the void, connecting us all in this shared wonder. Now, let's dive deeper into the enigma, where the lines between chance and intention begin to blur. Picture Saturn, that ringed giant, a beacon in our solar system with its swirling bands of gas and a family of over 80 moons, each a world unto itself. Titan, the largest, cloaked in a thick orange haze of nitrogen and methane, where lakes of liquid hydrocarbons pool on the surface, vast seas not of water, but of ethane and methane, rippling under winds that carve dunes from organic particles. Scientists have long marveled at this moon, calling it a frozen snapshot of early Earth, where complex chemistry brews without the spark of life we know. And then there's Enceladus, smaller but no less intriguing. Its icy crust, cracked like a shattered eggshell, spewing geysers of water vapor, salts, and organics into space plumes that stretch hundreds of kilometers, hinting at a warm, watery ocean hidden beneath, potentially teeming with the ingredients for microbial existence. These aren't wild fantasies. They're rooted in real observations from probes like Cassini, which orbited Saturn for 13 years, dipping through those plumes and tasting the chemistry of possible life. But in the summer of 2025, something shifted. Fresh analyses, powered by advanced simulations and spectral data from the James Webb Space Telescope, pointed to patterns in Titan's lakes that suggest not just random molecules, but processes that could mimic the birth of primitive cells, self-assembling structures in the methane soup, perhaps the precursors to something alive. On Enceladus, the organic compounds in those plumes, things like formaldehyde and hydrogen cyanide, were found in ratios that echo hydrothermal vents on Earth's ocean floors, places where life might have first emerged billions of years ago. NASA didn't declare life found. Of course, they're cautious, as they should be. But the announcement sent ripples through the scientific community. These moons aren't dead relics. They're dynamic, possibly nurturing environments where biology could take hold. And then, as if on cue, on July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, those vigilant telescopes in Hawaii, Chile, and South Africa spotted something extraordinary. an object streaking in from beyond our solar system, unbound by the sun's gravity, on a path that would bring it perilously close to Saturn's domain. This wasn't your ordinary comet, born in the frigid outskirts of our own neighborhood like Halley's or Hale-Bopp. No, 3I/Atlas boasts a hyperbolic trajectory, a mathematical curve that screams outsider, with an eccentricity greater than 1, meaning it's got enough velocity to escape the sun's pull forever after its visit. It's only the third such interstellar traveller we've confirmed, following the enigmatic cigar-shaped Oumuamua in 2017 and the more comet-like Borisov in 2019. But what sets this one apart is its chemistry, revealed through early glimpses from powerful instruments like the James Webb and Spherex telescopes. Its coma, that fuzzy envelope of gas and dust surrounding the nucleus, is dominated by carbon dioxide, with a ratio to water of about 8:1, one of the highest ever recorded. Most comets are dirty snowballs, rich in water ice that sublimes into vapor as they near the sun, creating those iconic tails. This one? It's like a frozen block of dry ice, exhaling carbon dioxide in a way that paints the void with an eerie green glow, possibly from dicarbon molecules or cyanide compounds breaking apart under stellar light. Now, here's where the intrigue deepens. This composition isn't just odd, it's eerily suited to Saturn's system. The rings of Saturn, those breathtaking bands of ice and rock, have long puzzled us with their youthful appearance. Spanning hundreds of thousands of kilometers but only tens of meters thick in places, they're composed mostly of water ice particles, from dust grains to boulder-sized chunks dusted with rocky silicates. Yet, despite the solar system's age of 4.5 billion years, the rings look pristine. Almost new estimates suggest they might be as young as 100 million years, around the time dinosaurs roamed Earth. How do they stay so clean and bright? Theories abound. Perhaps a moon shattered by tidal forces, or constant bombardment from micrometeorites darkening them over time. But what if interstellar visitors like 3I/Atlas play a role, delivering fresh ice and volatiles to replenish the rings, keeping them vibrant against the ravages of cosmic radiation and solar wind? Imagine the implications. As 3I/Atlas approaches, its outgassing could interact with Saturn's magnetic field, that colossal bubble trapping charged particles and creating auroras brighter than any on Earth. The comet's carbon dioxide-rich tail might seed the upper atmosphere of Titan, where it could react with the methane haze to form more complex organics, accelerating whatever chemical experiments are brewing in those alien lakes. On Enceladus, the added volatiles might mingle with the plumes, enriching the subsurface ocean with carbon compounds essential for life. Carbon, after all, is the backbone of biology as we know it. Is this mere coincidence, or something more? Some whisper of a cosmic gateway near Saturn, where the planet's immense gravity and magnetic pull act as a beacon, drawing in wanderers from other stars to nourish its moons and rings, maintaining a delicate balance that favors habitability. And the timing, the timing is what quickens the pulse. This comet will skim past Saturn on October 3rd, 2025, at a distance of about 28 to 30 million kilometers, close enough to feel the giant's gravitational tug, but far enough to avoid catastrophe. That's roughly 0.19 to 0.2 astronomical units. For those keeping score, a cosmic near miss that positions it near Titan's orbit. Then, on October 29th or 30th, it reaches perihelion, its closest brush with the Sun, just inside Saturn's path, where solar heat will maximize its activity, unleashing torrents of gas and dust. But during this crucial phase, from Earth's vantage, the comet will vanish behind the Sun's glare, a solar conjunction, creating weeks of observational blackout, as if the universe is drawing a curtain for a private performance. What secrets might unfold in that hidden interlude? Will the European Space Agency's orbiters, imagined successors to Cassini, perhaps equipped with new spectrometers, capture hints of the comet's influence on the rings, like fresh ice particles joining the eternal dance? Or will we detect subtle shifts in Titan's atmosphere, a spike in organics that pushes the moon closer to life's threshold? The green glow observed in September 2025 adds another layer of mystery emerald hues that could signal exotic chemistry from a distant stellar nursery, where conditions forged this traveler in ways alien to our system. As we ponder these questions, drifting towards sleep under the same stars that guide this wanderer, it's hard not to feel a thrill of connection to the grander scheme. 3I/Atlas isn't just a rock, it's a messenger, carrying echoes of other suns, other worlds, straight to the threshold of Saturn's realm. And in that delivery, perhaps lies the key to awakening dormant potentials on Titan and Enceladus worlds where life might already stir or wait patiently for the right spark. What if this interstellar guest is the catalyst, the missing ingredient in a cosmic recipe billions of years in the making? Stay with me, dear listener, as we unravel this tapestry thread by thread, for in the hush of the night, the universe reveals its wonders to those who listen closely. Delving deeper into the heart of our solar system's enigmatic guardian, Saturn stands as a colossal world of swirling storms and ethereal beauty, its rings a shimmering testament to the artistry of gravity and time. This gas giant, the second largest planet after Jupiter, spans about 120,000 kilometers across 9 times wider than Earth, wrapped in layers of hydrogen and helium that churn with winds howling at over 1,800 kilometers per hour. But it's not just the planet itself that captivates. It's the intricate family it nurtures, a realm of moons that challenge our very notions of where life might hide in the cosmos. Among them, Titan and Enceladus emerge as stars in their own right, worlds that blend the familiar with the utterly alien, teasing us with clues that perhaps we're not alone in this vast expanse. Let's start with Titan, Saturn's largest moon, a behemoth nearly as big as Mercury, shrouded in a thick, hazy atmosphere that's denser than Earth's own. Imagine a landscape where the air is mostly nitrogen, laced with methane and ethane, creating an orange veil that obscures the surface like a perpetual twilight. Down below, vast lakes and rivers flow not with water, but with liquid hydrocarbons, chilled to minus 180 degrees Celsius. These aren't mere puddles. Some lakes stretch hundreds of kilometers, their shores etched with dunes of organic particles, like tarry sands blown by gentle breezes. Scientists have pieced this together from data sent back by the Huygens probe, which parachuted through that haze in 2005, landing softly to reveal a world eerily reminiscent of early Earth, but frozen in a chemical deep freeze. What makes Titan so tantalizing is the ongoing dance of chemistry happening right now. Recent analyses from archived Cassini data, revisited with fresh eyes in 2025, have uncovered patterns suggesting that simple molecules in those methane lakes might be self-assembling into vesicle-like structures, tiny bubbles that could mimic the membranes of primitive cells. Picture it. In the frigid slosh of ethane and methane, hydrocarbons linking up, forming hollow spheres that trap other compounds inside, perhaps the first steps towards something that could replicate or evolve. This isn't confirmed life, of course, but it's a whisper of possibility, a hint that Titan's surface might be a natural laboratory brewing the precursors to biology. And just last month, on August 31st, 2025, NASA shared findings indicating active chemistry in the clouds above, where ultraviolet light from the sun breaks down methane into more complex organics, raining down as tholins, dark, sticky polymers that blanket the dunes and tint everything reddish-brown. These tholins are like nature's Lego blocks, stacking into chains that could, under the right conditions, spark metabolic processes. Shifting our gaze to Enceladus, a smaller moon but no less dramatic. This icy orb measures just 500 kilometers across, yet it harbors secrets that could rewrite our understanding of habitability. Its surface is a cracked mosaic of fresh ice, with tiger stripes, long fissures near the South Pole that spew towering plumes of water vapor, ice particles, and gases into space. These geysers, discovered by Cassini in 2005, erupt with the force of geothermal energy from below, hinting at a global ocean sloshing beneath the crust, kept liquid by tidal heating from Saturn's gravitational pull. That ocean isn't barren. Samples tasted by Cassini revealed salts, ammonia, hydrogen, and a cocktail of organic molecules, carbon chains, nitrogen compounds, even hints of phosphorus, all essentials for life as we know it. But here's where curiosity turns to intrigue. New studies released on September 9, 2025, complicate the picture. Researchers experimenting with lab simulations found that some of those organics in the plumes might not originate from the deep ocean at all, but could form when ice grains are blasted by radiation in Saturn's magnetosphere, breaking down simpler molecules into more complex ones. It's like the plumes are a canvas, painted by cosmic rays and charged particles, creating illusions of deeper biological activity. Yet, this doesn't dim the excitement. It adds layers. If radiation can forge organics on the surface, imagine what might happen in the protected warmth below, where hydrothermal vents similar to Earth's black smokers could nurture microbial ecosystems. Hydrogen cyanide detected in the mix echoes compounds vital for RNA formation, the ancient blueprint of life. And with phosphorus now confirmed in those plumes, Enceladus checks nearly every box for potential habitability. Liquid water, energy sources, and the right chemistry. Now, enter the uninvited guest. 3I/Atlas. This interstellar nomad detected on July 1st, 2025 by the watchful eyes of the Asteroid Terrestrial Impact Last Alert System telescopes. Unlike comets born in our Oort cloud, distant relics of the solar system's formation, this one hails from beyond its path, a hyperbolic arc that betrays origins around another star, perhaps ejected by gravitational chaos in a far-off system billions of years ago. As it barrels inward at over 30 kilometers per second, it's already shedding a coma. That glowing shroud of sublimating ices, dominated not by water but by carbon dioxide, in an 8:1 ratio with H2O. Early spectra from the James Webb Space Telescope show traces of carbon monoxide and carbonyl sulfide, compounds that hint at formation in a stellar nursery, where temperatures hovered just right for CO2 to freeze, while water stayed gaseous. This chemistry raises eyebrows, because it mirrors what Saturn's moons might crave. On Titan, where methane reigns, an influx of carbon dioxide could trigger reactions in the upper atmosphere, perhaps thickening the haze or seeding new organic pathways. For Enceladus, the added volatiles might enrich the plumes, providing carbon for any subsurface life to metabolize. But why this comet? Why now? Comparisons to previous visitors sharpen the mystery. Recall Oumuamua, spotted in October 2017, a reddish, cigar-shaped rock about 200 meters long, tumbling end over end without a visible coma or tail, its acceleration unexplained by gravity alone, sparking debates about solar sails or alien probes. It sped through without lingering, a silent scout from the stars. Then came Borisov in August 2019, more comet-like, with a fuzzy head and tail, its nucleus roughly a kilometer wide, spraying cyanide and other gases as it neared the Sunday. Borisov looked familiar, akin to our own comets, but with subtle differences in composition, like higher carbon monoxide levels, suggesting birth in a colder, more distant realm. Now, 3I/Atlas bridges the gap, natural in shape, no artificial signals, but with that peculiar CO, two dominants and a faint green tint from dicarbon or cyanide dissociation. It's as if each interloper reveals a new facet of interstellar diversity. Oumuamua, the rocky enigma, Borisov, the gassy wanderer, and Atlas, the carbon breather, each challenging our models of how objects form around other suns. Pondering this, one can't ignore Saturn's role as a potential cosmic magnet. The planet's magnetic field, though smaller than Jupiter's, is still 578 times stronger than Earth's, enveloping the rings and moons in a protective bubble that traps solar wind particles and creates dazzling auroras at the poles. This magnetosphere isn't passive. It interacts dynamically, accelerating ions and electrons that bombard incoming objects. For a comet like 3I/Atlas, approaching this field could induce its own temporary magnetotail, a stream of charged particles stretching away from the Sun, potentially altering its outgassing or even depositing material onto nearby moons. Some theorists speculate that Saturn's immense gravity and magnetic reach act like a portal, subtly influencing trajectories of distant visitors, pulling them in from the interstellar medium. It's not science fiction. Planetary magnetospheres do deflect and capture dust and plasma, and in Saturn's case, the field weaves through the rings, eroding particles and contributing to the E-ring, largely fed by Enceladus's plumes. Could this explain why Atlas targets Saturn? Perhaps its path, set eons ago, was nudged by subtle gravitational encounters. But the magnetosphere's pull might fine-tune the approach, drawing it closer to Titan or Enceladus. Imagine the comet's tail mingling with Titan's haze, introducing CO2 that reacts with methane to form carbonates or more intricate organics, pushing the moon's chemistry toward greater complexity. Or, as it skirts Enceladus, fragments of ice laced with cyanide compounds could seed the ocean vents, providing nutrients for hypothetical microbes. These ideas stir the imagination, blending hard data from Cassini, which mapped the magnetosphere's twists and the plume's contents with the thrill of what-if scenarios. As observations pour in, the green glow intensifies, a spectral signature that might trace back to the comet's birthplace, a system rich in carbon where dicarbon molecules formed in dense nebulae. Spherex telescope data confirms water ice buried deeper, suggesting layered composition, perhaps a core processed by cosmic rays during its million-year voyage through the void. This layering could mean that as Atlas heats up nearing perihelion, its chemistry evolves, revealing hidden reservoirs that surprise us further. Unlike Oumuamua's mysterious speed-up, attributed to outgassing we couldn't see, or Borisov's predictable tail, Atlas seems poised for transformation, its CO2 coma potentially fragmenting into smaller particles that Saturn's gravity could capture, adding to the ring's eternal sparkle. The portal theory gains traction when considering how Saturn's field interacts with solar wind, creating bow shocks and magnetotails that extend millions of kilometers. Incoming objects like comets encounter this as a barrier, their own induced fields clashing, sometimes leading to enhanced activity or trajectory tweaks. For an interstellar visitor, unaccustomed to our sun's wind, this encounter could be dramatic, amplifying its glow or even causing structural changes. Recent models suggest that such interactions might explain the ring's youthfulness, constant replenishment from captured volatiles, keeping them from darkening over time. Tying this back to the moon's, Titan's tholins, those organic hazes, might owe part of their existence to similar processes. A study from 2024 proposed that meteoroids from Enceladus, ejected by plumes and caught in Saturn's field, impact Titan's atmosphere, contributing to the haze. If Atlas adds to this, it could accelerate the buildup, creating thicker layers that insulate the surface, perhaps warming pockets enough for chemical reactions to quicken. On Enceladus, the radiation-forged organics in plumes add another puzzle. If they're surface-made, does that mean the ocean below is even richer, protected from the harshness above? These threads weave a narrative of interconnection, where a lone traveler from afar becomes part of Saturn's symphony, its chemistry harmonizing with the moon's potential for life. As we await the flyby, the questions mount. Will Atlas's passage ignite auroras brighter than ever, visible from our telescopes? Might it leave a trail of carbon that future probes detect, proving interstellar delivery shapes worlds? The universe, in its quiet wisdom, invites us to watch, to wonder, and to dream of the possibilities unfolding in Saturn's shadowed embrace. As you join me in this contemplation tonight, I find myself curious about your own corner of the world. Where are you listening from right now? Under what sky? And what time is it there in your quiet moment? The enigma of 3I/Atlas deepens when we peer into its chemical heart, a composition so peculiar it feels like a riddle scripted by the stars themselves. At the core of this interstellar wanderer lies a dominance of carbon dioxide that's not just unusual, it's profoundly out of step with what we've come to expect from comets in our own backyard. Early readings from the James Webb Space Telescope, that marvel of human ingenuity orbiting 1,000,000 miles from Earth, paint a picture of a coma where CO2 outweighs water vapor by a staggering 8-to-1 ratio. That's like finding a snowball made mostly of dry ice, sublimating into a misty veil that's more greenhouse gas than frozen water. And woven into this mix are traces of carbon monoxide and carbonyl sulfide, subtle companions that whisper of formation in environments far stranger than our solar system's icy fringes. These details emerged in the weeks following its discovery on July 1st, 2025, as astronomers turned their instruments skyward, capturing spectra that break down the light from the comet's glow into a rainbow of chemical fingerprints. The SphereX telescope, with its infrared eyes designed to map the universe's molecular landscape, confirmed these findings independently, ruling out contamination from Earth's atmosphere or instrumental glitches. But what truly captivates is the green hue that began to emerge in ground-based observations. Around mid-September 2025, a soft emerald shimmer in the coma, likely born from dicarbon molecules, those paired carbon atoms that fluoresce under ultraviolet bombardment, or perhaps cyanide compounds fragmenting in the harsh vacuum. It's a color that evokes ancient alchemical mysteries, a verdant signal from the void that makes you wonder if this visitor carries echoes of distant stellar forges where carbon reigned supreme. To grasp why this matters, consider how comets typically behave. Our familiar ones, like those from the Kuiper Belt or Oort cloud, are repositories of primordial ices, mostly water, with dashes of methane, ammonia, and carbon dioxide frozen in since the solar system's dawn 4.5 billion years ago. As they loop closer to the sun, heat awakens them, turning solid to gas in a process called sublimation, birthing tails that can stretch millions of kilometers. But 3I/Atlas defies this script. Its CO2 heavy makeup suggests it formed in a snow line unique to its original star system, a boundary where temperatures allowed carbon dioxide to solidify, while water might have remained vapor, perhaps around a cooler red dwarf star, or in a disk rich with carbon from supernova remnants. Or maybe eons of interstellar travel exposed its surface to cosmic rays, those high-energy particles zipping through the galaxy, processing the outer layers into a carbon-rich crust that now exhales preferentially when warmed. This chemistry doesn't exist in isolation. It beckons us to imagine interactions with Saturn's realm that could rewrite the story of its rings and moons. Picture the comet's outgassing plume encountering the rings, those delicate disks of ice particles orbiting in precise harmony. The rings' brightness has long puzzled us. They reflect sunlight like fresh snow, defying the darkening effects of billions of years under micrometeorite bombardment and radiation. A fresh influx of CO2-laden ice from Atlas could act like cosmic rain, depositing volatile grains that replenish the rings, preventing them from fading into obscurity. It's a tantalizing hypothesis. Interstellar deliveries as the secret to their eternal youth, each visitor adding a layer of frost that scatters light anew. Extending this to Titan, the comet's carbon payload might mingle with the moon's methane-dominated atmosphere, sparking reactions that build more complex organics. Titan's haze already produces tholins, those reddish polymers that fall like soot, accumulating on the surface. Introduce CO2, and you could see catalytic chains forming, perhaps creating carbonates or even amino acid precursors in the upper layers, where solar energy drives the alchemy. It's like adding a missing ingredient to a simmering pot, potentially accelerating the moon's natural experiments towards something resembling prebiotic soup. And on Enceladus, where plumes eject ocean material into space, the comet's cyanide traces those nitrogen-carbon bonds could seed the subsurface sea, providing building blocks for nucleic acids or proteins if life lurks there. Cyanide, after all, plays a role in theories of life's origins on Earth, forming the backbone of molecules like adenine in RNA. Yet, the proof of its extraterrestrial birth lies in the math of its motion, a hyperbolic orbit that seals its status as an outsider. In orbital mechanics, shapes tell tales. Circles are perfect harmony, ellipses the bound paths of planets and comets tied to the sunday. But when eccentricity climbs above one, you're dealing with a trajectory that's open-ended, a one-way ticket through the system. For 3I/Atlas, calculations from multiple observatories pin its eccentricity well over that threshold, meaning it entered our neighborhood with excess speed, enough to slingshot past the sun and vanish back into the interstellar deeps, never to return. This isn't speculation. It's derived from precise tracking, plotting its position against the stars night after night, confirming a velocity that no solar system object could muster without a boost from beyond. Contrast this with Oumuamua's path in 2017, also hyperbolic, but with a flatter curve, suggesting a gentler ejection from its home. Borisov in 2019 traced a steeper arc, its speed hinting at a more violent expulsion. Perhaps from a binary star system's chaos, Atlas falls between them, its curve calculated to peak at perihelion just inside Saturn's orbit, maximizing solar heating precisely when it's nearest the ringed world. This alignment fuels curiosity. Is it chance, or does the galaxy's architecture favor such rendezvous, where gravity wells like Saturn's act as nets, capturing wanderers to enrich their domains? Delving into the green glow offers more layers of intrigue. Dicarbon, or C2, forms when carbon atoms bond in high-energy environments, glowing green as electrons jump. States a phenomenon seen in our comets but amplified here, perhaps due to higher concentrations from Atlas's carbon-rich birth. Cyanide, meanwhile, breaks down into radicals that could react with Titan's nitrogen, forming nitriles compounds detected in the moon's haze that mirror prebiotic chemistry on early Earth. Imagine Atlas as a seed pod, bursting open near Saturn, scattering molecular gifts that could tip the balance toward life on Enceladus's ocean floor, where vents spew hot, mineral-rich water, fostering conditions akin to Earth's deep-sea oases. But questions linger about its nucleus, the hidden core beneath the coma. Estimates suggest it's a few kilometers across, irregular like a potato tumbled through space, its surface pocked with craters from ancient impacts. As it warms, deeper layers might reveal water, ice, or even ammonia, shifting the ratio and unveiling a stratified history. Outer shells baked by radiation, inner hearts preserving pristine material from its stellar cradle. This evolution could be observed post-perihelion, when Atlas emerges from the sun's glare in late November 2025, potentially transformed, its tail faded but secrets laid bare. The rain idea gains traction when considering Saturn's E-ring, that diffuse outer band fed by Enceladus's plumes. If Atlas's particles get caught in the magnetosphere, they could spiral inward, joining this ring and extending its life. Models from 2024 simulations show how cometary dust can migrate through magnetic fields, depositing volatiles that prevent sublimation loss. For Atlas, with its CO2 bias, this could introduce greenhouse effects on Titan's surface pockets, trapping heat and melting ices temporarily, stirring chemical pots. Pushing further, what if this chemistry hints at deliberate design, not alien tech, but natural selection on cosmic scales? Stars with carbon-rich disks might preferentially eject such objects, seeding systems like ours with materials that foster complexity. Atlas could be one of many, a galactic delivery service maintaining habitability, or, in wilder thoughts, a relic from an ancient civilization's experiment, engineering comets to carry seeds to ocean worlds like Enceladus, where liquid water awaits. These speculations keep the mind racing, blending data with wonder. As Atlas hurtles closer, its anomaly challenges us to rethink interstellar diversity comets as bridges between stars, carrying chemistry that could ignite life anew. What revelations await in its spectral lines, or in the subtle shifts it might imprint on Saturn's moons? The cosmos holds its breath, inviting us to listen for the answers in the silence of space. As the calendar edges toward October 3rd, 2025, the stage is set for a celestial drama unlike any we've witnessed, a close encounter between 3I/Atlas and the ringed colossus of our solar system, Saturn. This isn't a distant glimpse through a telescope. It's a rendezvous at approximately 28 to 30 million kilometers, a distance that, in the grand scale of space, feels intimate, like two ancient travelers brushing shoulders in the void. That's roughly 0.19 to 0.2 astronomical units. Close enough for Saturn's immense gravitational influence to tug gently at the comet's path, potentially altering its trajectory in subtle ways that astronomers will scrutinize for years. Imagine the scene. Atlas, this carbon dioxide-laden wanderer from the stars, sweeping past the planet's outer fringes, its coma expanding under the sun's growing warmth, while Saturn's rings glitter like a cosmic halo, undisturbed yet possibly enriched by the visitor's fleeting presence. This flyby marks the pivotal moment in Atlas's journey through our neighborhood, a point where speculation meets observable reality. By this date, the comet will have accelerated, its velocity peaking as it dives inward, shedding more gas and dust with each passing hour. Perihelion follows on October 29th or 30th, when Atlas skims closest to the Sun, just inside Saturn's orbital path at about 1.4 astronomical units from our star. At that apex, solar radiation will intensify the outgassing, turning the comet into a blazing fountain of volatiles, carbon dioxide streaming out in vast quantities, mixed with whatever deeper ices awaken from their slumber. It's here, in this heated frenzy, that Atlas could reveal its true nature, perhaps fragmenting or brightening dramatically, offering clues to its layered composition. But here's the twist that adds a layer of cosmic suspense. During much of this critical phase, from late September through late October 2025, Atlas will be lost to Earth's view, hidden behind the sun's blinding glare in what's known as solar conjunction. Our ground-based telescopes, no matter how powerful, will stare into emptiness, their senses overwhelmed by solar light. It's as if the universe has conspired to grant privacy to this encounter. A blackout period where whatever transpires between the comet and Saturn unfolds unwatched by human eyes. This isn't unprecedented spacecraft. Like Voyager and Cassini navigated similar alignments. But the timing feels orchestrated, aligning maximum activity with minimal observation, leaving us to piece together the story from fragments, before and after. Fortunately, we're not entirely blind. The European Space Agency, building on the legacy of Cassini, which ended its mission in 2017, has positioned conceptual successors, advanced orbiters equipped with spectrometers, cameras, and particle detectors to monitor Saturn's system. These aren't real-time probes in 2025, but let's envision them as evolved guardians. Perhaps a new mission launched in the early 2020s, circling the planet to study its atmosphere, rings, and moons. During the flyby, they could capture high-resolution images of Atlas's nucleus, analyzing its shape and surface features, perhaps revealing craters or jets spewing gas asymmetrically. Ultraviolet spectrometers might dissect the coma's emissions, spotting lines from cyanide or dicarbon that confirm the green glow's source, while dust analyzers snag particles from the tail, providing direct samples of interstellar material without needing a rendezvous mission. What makes this encounter electric is the potential for dynamic interactions. As Atlas approaches, it will plunge into Saturn's magnetosphere, that vast magnetic bubble extending over 1 million kilometers, shaped like a teardrop by the solar wind. This field isn't static. It's a turbulent sea of plasma, where charged particles spiral along field lines, creating radiation belts that would fry unprotected electronics. For the comet, this immersion could induce its own magnetic effects. Comets develop temporary magnetotails when their ions interact with solar wind. But near Saturn, the planet's field might amplify this, causing enhanced outgassing or even electrical discharges. Picture bolts of plasma arcing between the comet and the magnetic lines, lighting up like faint lightning in the dark. This could manifest as spectacular auroras on Saturn's poles, those shimmering curtains of light caused by particles slamming into the atmosphere. Normally driven by solar wind, an interloper like Atlas might inject extra ions, igniting displays brighter and more widespread than usual greens and purples dancing across the gas giant's cloud tops. Visible, perhaps even from Jupiter's vicinity if we had eyes there. It's a phenomenon we've seen hints of before. Cassini observed auroral brightenings linked to Enceladus's plumes, where water ions feed the field. If Atlas contributes CO2 ions, it might alter the aurora's chemistry, producing unique spectral signatures that orbiters could detect, offering a window into how interstellar material integrates with planetary systems. Extending the curiosity to the rings, Atlas's passage might deliver a subtle boon. The rings, divided into bands like A, B, and C, are dynamic structures, constantly evolving through collisions and gravitational resonances with moons. Particles erode over time, sublimating or being lost to Saturn's atmosphere. Yet they persist with surprising purity. A comet flyby could scatter dust and ice grains into this mix, particularly if Atlas fragments under tidal stress. Saturn's gravity, though gentler than Jupiter's, could still strain a fragile nucleus. These additions might brighten certain ringlets or create temporary spokes, those radial features seen in Voyager images, caused by electrostatic levitation of fine dust. More intriguingly, CO2 ice from Atlas could coat ring particles, protecting them from darkening radiation, or even sublimate to form a tenuous atmosphere around the rings themselves, a ghostly envelope detectable by sensitive instruments. Turning to the moons, the proximity to Titan during the flyby Atlas's path skims near its orbit, opens doors to fascinating what-ifs. Titan's thick atmosphere acts like a shield, but a cometary tail could penetrate, depositing volatiles that rain down. Carbon dioxide mixing with methane might form clathrates, cage-like structures, trapping gases, or trigger photochemical reactions in the haze, producing more tholins or even simple sugars. This isn't idle fancy. Lab experiments simulating Titan's conditions have shown how external inputs accelerate complexity, potentially bridging the gap from chemistry to biology. If Atlas's cyanide compounds join the fray, they could enhance nitrile formation, molecules key to prebiotic pathways, perhaps tipping Titan's lakes toward hosting self-replicating systems. For Enceladus, the interaction might be even more direct. The moon's plumes, erupting from those tiger stripes, create a diffuse cloud that extends into space, intersecting potential comet paths. If Atlas's trajectory aligns just right, its outgassing could mingle with these ejections, enriching them with carbon and nitrogen. Envision water vapor from the plumes condensing on cometary dust, forming hybrid particles that fall back to the surface or escape into the rings. This exchange could introduce organics to the subsurface ocean, where hydrothermal vents provide energy hydrogen from serpentinization reactions, fueling potential microbes. Recent models suggest such infusions happen sporadically, maintaining chemical gradients essential for life. The safety of this event reassures. Atlas poses no threat to Earth. Its closest approach in mid-December 2025 at 1.8 astronomical units, farther than the Sun itself. But for Saturn, it's a gentle nudge, a whisper of change. No collisions anticipated, the distance ensures that but gravitational perturbations might resonate through the system, slightly altering moon orbits or ring densities over eons. As October 3rd nears, the anticipation builds, a reminder that in the dance of planets and comets, every encounter holds potential for revelation, urging us to keep watching the skies with wide-eyed wonder. And if this cosmic journey has you hooked, why not subscribe and hit that bell to stay tuned for more mysteries unfolding right here, between stars. If anomalies appear, unexpected accelerations or chemical shifts, it might hint at unknown physics, like dark matter influences or exotic ices. Pondering broader implications, this moment underscores Saturn's role as a cosmic crossroads, its gravity well drawing in wanderers to refresh its worlds. What if such events are routine, interstellar comets as fertilizers for habitability? Atlas might be a harbinger, teaching us that life emerges not in isolation, but through galactic connections. The blackout adds tension, will post-conjunction views show a transformed comet, its secrets spilled, or evidence of integration, like ring brightening or plume enhancements. As October 3rd nears, the anticipation builds, a reminder that in the dance of planets and comets, every encounter holds potential for revelation, urging us to keep watching the skies with wide-eyed wonder. Behind the veil of cosmic coincidence lies a question that tugs at the edges of reason. Why does 3I/Atlas arrive precisely now in 2025? Syncing with humanity's fresh revelations about Saturn's moons, it's a timing so sharp it borders on the uncanny. as if the stars themselves have aligned to deliver this carbon-rich messenger, just as we're uncovering hints of organic complexity on Titan and Enceladus. NASA's announcements in August and September 2025 didn't come from thin air. They stem from painstaking reanalysis of Cassini data, bolstered by James Webb observations, showing methane cycles on Titan that could self-sustain prebiotic reactions and plume compositions on Enceladus that mirror Earth's life-friendly vents. Yet here comes Atlas, unbidden, its hyperbolic path set millions of years ago, poised to brush Saturn's domain in October. Correlation whispers, but does it speak of causation, or merely the mind's hunger for patterns in the chaos? To unravel this, let's trace the threads of doubt that weave through the astronomical community. Skeptics point to the inexorable laws of celestial mechanics. Atlas's orbit, hyperbolic and unbound, was forged in the gravitational turmoil of a distant star system, perhaps a close encounter with a rogue planet, or a stellar flyby that flung it into the interstellar gulf, eons before humans gazed upward. Its velocity, clocked at over 30 kilometers per second upon entry, carries the imprint of that ancient ejection. No mid-course corrections, no hidden propulsion, just Newton's unyielding grip guiding it through our system. The fact that it coincides with our discoveries? Pure serendipity, they argue, like drawing a royal flush in the infinite casino of the cosmos. After all, interstellar objects zip through solar systems all the time. We've only spotted 3 because our detection nets are still coarse. As surveys like the Vera C, the Rubin Observatory come online in the coming years, we might find these visitors are as common as cosmic dust. Their arrivals, random dots on a timeline that cares nothing for human milestones. But the whispers grow louder when you stack the coincidences. First, the perihelion geometry. Atlas reaches its solar closest on October 29th or 30th, positioning it just inside Saturn's orbit for peak heating, when outgassing surges like a volcanic eruption in space. This maximizes the release of its CO2 cargo precisely near the ringed planet, as if timed to deliver volatiles where they might interact most profoundly with Titan's hazy skies or Enceladus's icy breaths. Then there's the solar conjunction, that veil of invisibility from late September to late October 2025, cloaking the encounter from Earth's prying eyes during the comet's most active phase. It's a window of cosmic privacy, where any subtle exchanges, dust settling into rings, gases mingling with plumes happen off-stage, leaving us to infer from before and after snapshots. Add the chemistry. CO2, ideal for enhancing Titan's greenhouse effects or enriching Enceladus's ocean chemistry, arriving when we're debating if those moons host active prebiology. The odds feel stacked, prompting some to ask if the universe plays favorites, channeling such events to systems ripe for evolution. This leads to a bolder speculation. What if Saturn serves as the solar system's gatekeeper, a gravitational sentinel that subtly attracts interstellar wanderers to sustain its habitable niches? Picture the planet not as passive, but as a dynamic hub, its massive gravity well 9.5 times, Earth's creating ripples in space-time that nudge incoming objects toward it, combined with the magnetosphere's reach, extending like invisible arms. It could act as a cosmic funnel, drawing in comets from the Oort cloud analogues of other stars. In this living universe framework, systems like ours evolve through such infusions, where interstellar chemistry fertilizes potential life zones. Titan, with its organic-rich lakes, might owe its complexity to past visitors. Enceladus's plumes could be periodically refreshed, maintaining chemical disequilibria essential for metabolism. Atlas, then, isn't an anomaly, but a participant in a galactic ecology, where comets are pollinators, carrying elements between stars to keep worlds vibrant. Evidence for this isn't ironclad, but tantalizing breadcrumbs exist. Studies from 2023 using Gaia satellite data mapped rogue objects' paths, suggesting dense stellar neighborhoods eject more volatiles toward giant planets. Saturn's rings, puzzlingly young at perhaps 100 million years, might rely on such deliveries to counteract erosion, micrometeorites, and radiation would otherwise dull them over billions of years. If Atlas contributes even a fraction of its mass, it could explain anomalies like the E-ring's brightness, fed by Enceladus, but possibly augmented by outsiders. On a speculative note, if the universe favors habitability, mechanisms like this could be built in. A natural selection on cosmic scales where systems that attract replenishers thrive, birthing complexity more readily. Yet, the rational counterpoint holds firm. No design needed when probability suffices. Interstellar space teems with trillions of such objects. One brushing Saturn every few decades isn't improbable, especially as our detection sharpens. The timing with our discoveries? We're in an era of exponential insight. James Webb's infrared prowess unveiling molecular details on Titan that Cassini hinted at but couldn't resolve. Its anthropocentric bias to see purpose. The comet's path predates our species by epochs, indifferent to our calendars. This duality science's sober lens versus speculation's allure fuels endless debate in observatories and online forums. Forums buzz with theories. Is Atlas a terraforming probe in disguise? Its natural facade masking engineered delivery? NASA dismisses this, citing no signals or maneuvers. But the blackout period stirs paranoia. What if subtle adjustments occur unseen? Others invoke panspermia twists. Perhaps Atlas carries dormant microbes from its origin, seeding Enceladus's ocean during flyby. Exploring from a historical vantage, comets have always sparked such tension. Ancient Chinese astronomers logged them as broom stars, omens of change. Europeans in the 1600s tied them to plagues. Halley's comet in 1910 triggered panic over cyanide gas, yet it passed harmlessly. Atlas echoes this. Its green glow reviving old fears, but now with data-driven curiosity. What if these events mark evolutionary leaps, comets as catalysts, their timing syncing with civilizations ready to interpret them? Philosophically, this probes the anthropic principle. We observe Atlas now because we're technologically mature enough to detect it and ponder its ties to Saturn's potential life. In a multiverse of possibilities, we inhabit one, where such alignments spark wonder, driving progress. Speculatively, if the universe is alive, Saturn as gatekeeper implies a self-regulating cosmos, where giants like it orchestrate infusions to nurture moons into cradles of biology. Doubt creeps in through observational gaps. With only months to study Atlas before conjunction, data remains preliminary. Spectra evolve as it heats. Initial ratios might shift, revealing water dominance deeper in. Online, this fuels wild claims, alien artifacts, or time capsules. But experts, like those at Queen's University Belfast, stress consistency with nature. No impossibilities yet. The living universe idea intrigues because it bridges gaps without invoking intelligence. Natural processes could evolve systems where giants attract comets, sustaining habitability. Atlas, as example, its CO2 suiting Titan's needs feels purposeful, but emerges from stellar chemistry norms. As October looms, the tension builds. What patterns will emerge? Will post-conjunction data show ring changes or plume enrichments, validating the gatekeeper role? Or reinforce randomness, a beautiful accident in infinity? This timing challenges us to embrace ambiguity. where doubt fuels discovery, keeping the cosmos eternally fascinating. Even as the data streams in from distant observatories, a shadow of uncertainty lingers over 3I/Atlas, like a faint mist obscuring the full picture of this interstellar enigma. With only a few short months since its detection on July 1st, 2025, astronomers have scrambled to gather every scrap of information before the solar conjunction blackout in late September swallows it from view. That's barely enough time to establish basic parameters. Its size, roughly a kilometer across based on brightness estimates. Its rotation, tumbling every few hours as inferred from light curve variations. Or its density, hinted at by how it responds to subtle gravitational pulls. Yet, these snapshots are incomplete. Snapshots frozen in the comet's current state, before the sun's heat delves deeper into its nucleus, potentially unveiling layers that could rewrite everything we think we know. This scarcity breeds doubt, a fertile ground where questions sprout like weeds in an untended garden. How reliable are those early spectra from the James Webb Space Telescope, captured when Atlas was still far out, its coma just beginning to form? Atmospheric interference on Earth, even for space-based instruments, can skew readings, especially for faint signals like the green glow that appeared in September 2025. Ground telescopes in Hawaii and Chile caught it first, a subtle emerald tint that waxed and waned, but follow-ups from SphereX refined it, attributing the color to dicarbon fluorescence or cyanide dissociation. Still, variations in observational conditions, cloud cover, light pollution, or the comet's changing distance mean these measurements carry error bars wide enough to hide surprises. What if the glow intensifies near Saturn, revealing not just chemistry, but interactions with the planet's radiation belts that alter its hue or intensity in ways we can't predict? The online world amplifies this ambiguity, turning quiet uncertainties into roaring debates that echo across forums, social media, and video streams. In the days following the discovery, hashtags like Interstellar Atlas and Saturn Visitor exploded, drawing in amateur astronomers, conspiracy enthusiasts, and armchair physicists alike. Threads on platforms like Reddit dissect every data point. One user points out how the CO2 ratio mirrors experimental setups for terraforming simulations, sparking hundreds of replies debating if Atlas could seed Titan's lakes with life-friendly compounds. Another highlights the timing, linking it to ancient myths of celestial messengers, fueling speculation that this isn't random, but a recurring cycle we've only now detected. Yet, amid the excitement, misinformation creeps in. Doctored images of the comet showing geometric shapes, or claims of radio bursts that official sources debunk as interference from satellites. Algorithms love this chaos, pushing extreme views to the top, where a single viral post can overshadow peer-reviewed papers, creating echo chambers that distort the science. At the heart of these discussions lies the ultimate litmus test. What would prove Atlas is more than natural, perhaps artificial or guided? The criteria are clear, drawn from decades of searching for extraterrestrial intelligence. First, anomalous maneuvers, sudden velocity changes, or course corrections defying gravity alone, like Oumuamua's subtle acceleration in 2017, which some attributed to outgassing but others whispered of sails. Atlas shows none. Its path follows predictable arcs, tracked by networks like the Center for Near-Earth Object Studies, with no deviations beyond expected perturbations from Jupiter's distant pull. Second, structured signals, narrowband radio emissions, or modulated light patterns that scream intelligence, not noise. Radio telescopes like the Green Bank Observatory have listened intently since July, scanning frequencies from low to high, but silence reigns, no pings or patterns emerging from the static. Third, geometric perfection, sharp edges, or symmetrical forms in high-resolution images, hinting at construction rather than erosion. Early Hubble shots show a lumpy, irregular nucleus, fuzzy at the edges, consistent with a battered space rock, not a crafted probe. Yet, the absence of these signs doesn't fully quell the curiosity. It invites deeper probing into what we might be missing. Enter the uncertainty effect, that psychological quirk where incomplete information sparks our brains to fill gaps with stories, often the most compelling ones. In Atlas's case, the short observation window, less than 4 months before conjunction, means we've only seen its outer skin, the surface volatiles responding to mild heating. As it nears perihelion on October 29th or 30th, solar warmth could penetrate deeper, stripping away layers to expose a core rich in water or organics, shifting the CO2 dominance to something more familiar. This evolution isn't hypothetical. Comets like Borisov in 2019 transformed mid-journey, its tail lengthening and composition varying as ices melted sequentially. If Atlas follows suit, post-conjunction views in November 2025 might reveal a new comet, brighter or dimmer, its green glow faded or amplified, forcing us to revise origin theories perhaps from a carbon star system where dicarbon abounds, or processed by interstellar clouds that enriched its cyanide. This ties into a bolder, more ethereal angle. What if the uncertainty opens doors to dimensions beyond the physical, linking Atlas to metaphysical portals near Saturn? Ancient lore speaks of ringed planets as gateways. Saturn, named for the Roman god of time, symbolized boundaries between realms in astrology and myth. In modern twists, some speculate the planet's hexagonal storm at its north pole, a bizarre six-sided vortex discovered by Cassini in 2006, might be a natural wormhole or energy conduit, influenced by magnetic fields that warp space-time subtly. Could Atlas, drawn by this, carry messages not in radio waves, but in quantum-entangled particles, or informational patterns embedded in its chemistry? It's a leap, blending physics with philosophy, but the uncertainty effect makes it alluring our minds. Evolved to spot predators in rustling bushes, now conjure portals in cometary tales, especially when data gaps allow imagination to roam. Delving into these gaps reveals practical challenges too. The comet's speed, 30 kilometers per second, makes detailed imaging tricky. It blurs across the sky, requiring adaptive optics and long exposures that risk overexposure from nearby stars. Distance compounds this. At discovery, Atlas was billions of kilometers out, its light faint, forcing reliance on large apertures like the Very Large Telescope in Chile. As it closes in, brightness increases, but so does the risk of saturation in detectors. Moreover, dust in the coma can scatter light, masking the nucleus, much like fog hiding a ship's hull. These limitations mean our portrait is impressionistic, not photographic, leaving room for interpretation and misinterpretation. Online, this feeds a spectrum of theories. Rational voices, like those from the International Astronomical Union, emphasize natural explanations. Atlas as a pristine sample of exosolar chemistry, its timing a fluke in our improving detection. But fringe corners buzz with intrigue claims of suppressed data, where governments hide signals because Atlas probes Saturn's secrets, like hidden bases on Titan or Enceladus's ocean harboring ancient life. These echo historical panics, like the 1938 War of the Worlds broadcast, but now amplified by digital speed. Yet, transparency counters this. Raw data from Atlas telescopes publishes hourly, open to all, making cover-ups improbable in our connected age. The uncertainty ties back to human psychology. where doubt seeds innovation. Gaps in knowledge drove Galileo's telescope in 1610, revealing Saturn's ears early glimpses of rings. Today, Atlas's mysteries spur calls for new missions. Perhaps a fast flyby probe to sample its tail, or enhanced orbiters at Saturn to watch the encounter up close. If post-perihelion changes show fragmentation, it could confirm a fragile structure, battered by cosmic rays. If the green glow persists, it might point to ongoing reactions, like photodissociation, creating radicals that recombine in novel ways. Spiritually, the portal idea resonates because Saturn symbolizes thresholds crossing into unknown realms. If Atlas traverses this, its message might be existential, a reminder that uncertainty is the universe's gift, pushing us to explore. Perhaps the comet's Loi, revealed after heating, holds isotopic ratios alien to our system, proving origins from a metal-poor star, or traces of heavy elements from supernovae. As 2025 unfolds, Atlas revives these echoes, its path a bridge from ancient awe to modern inquiry. What forgotten lore might it stir, or new myths birth? In this interplay, history and sky converge, inviting endless curiosity. And as we pause here in the telling, I'm drawn to wonder about you, dear listener. Where in the world are you tuning in from at this very instant? And what hour marks the time on your clock? Tracing the arc of 3I/Atlas back through the annals of human observation reveals a tapestry rich with wonder, where comets and planets like Saturn have long danced in the collective imagination, shaping myths that echo across millennia. Long before telescopes pierced the veil of night, ancient skywatchers chronicled fleeting visitors from the void, interpreting their fiery trails as divine missives or harbingers of fate. Consider the Sumerians, those early stargazers of Mesopotamia around 4,000 years before the Common Era, who etched comet sightings onto clay tablets, viewing them as arrows loosed by the gods, piercing the celestial order to signal upheaval on Earth. Their epics, like the Enuma Elish, spoke of cosmic battles where wandering stars disrupted harmony, much like Atlas now disrupts our neat models of the solar system with its uninvited passage near Saturn. This historical lens sharpens when we focus on Saturn itself, a planet whose slow, stately orbit, taking nearly 30 Earth years to circle the Sun, earned it a place of reverence and mystery in ancient lore. In Roman mythology, Saturn was no mere wanderer, but a god of profound duality, patron of agriculture and abundance, yet also the embodiment of time's inexorable march, devouring his own children in tales borrowed from the Greek Cronus. Cronus, the Titan who ruled a golden age before being overthrown, symbolized cycles of creation and destruction, his sickle a tool for harvest and severance alike. It's intriguing to ponder if early observers, glimpsing Saturn's faint rings through primitive lenses or naked eyes under pristine skies, saw in them a crown or chains, binding the god to his eternal watch. Babylonian astronomers, as far back as the 8th century before the Common Era, associated Saturn with Ninurta, a warrior deity linked to farming and storms, but also with the son of night, a shadowy counterpart to the day star, illuminating the dark hours with subtle influence. Diving into these associations stirs curiosity about how Atlas, with its green-tinged coma and carbon dioxide breath, might fit into such narratives. If Saturn represents time's guardian, could this comet be a century from the past, carrying frozen echoes of ancient stellar events to the present? The green glow, evoking emerald hues of alchemical transformation, mirrors motifs in Egyptian mythology, where Saturn aligned with Ptah, the creator god who shaped the world from chaos. Egyptians tracked planetary motions meticulously, their calendars tied to Sirius's rising, but comets disrupted this predictability, often seen as manifestations of Sekhmet, the lioness goddess of destruction, her fiery mane streaking the sky to herald plagues or conquests. Imagine ancient priests atop pyramids, charting Atlas-like visitors, interpreting their proximity to Saturn as a clash between order and intrusion, a theme that resonates today as we question if this comet's timing near the ringed planet signals a deeper cosmic rhythm. Shifting to the east, Chinese chronicles from the Han Dynasty, around 200 years before the Common Era, detail over 500 comet appearances, classifying them by shape, broom-like tails, foretold sweeping changes. While headless ones promised royal deaths, Saturn, known as Zhengxing, or the town star, governed stability and boundaries in their five-element system, associated with Earth and the color yellow. A comet nearing it might symbolize boundary breaches, like foreign invasions or internal rebellions. The Great Comet of 44 before the Common Era, visible for months, coincided with Julius Caesar's assassination, fueling Roman augurs to see it as his soul ascending or a warning unheeded. Such events tore Mars. Was Atlas's path etched in similar portents? Its discovery in 2025, aligning with global shifts in space exploration, as probes eye Titan's lakes for signs of alien chemistry. Mayan astronomers, masters of precise calendars in the Classic period, from 250 to 900 Common Era, viewed comets as smoking stars, emissaries from the underworld, Xibalba, disrupting the orderly march of Venus and Saturn. Saturn, linked to their god of agriculture and time, mirrored Cronus in overseeing cycles of planting and harvest. Their codices, like the Dresden Codex, blend astronomy with prophecy, where planetary conjunctions with comets predicted famines or wars. If they could witness Atlas's approach, might they see it as a serpent uncoiling towards Saturn's rings, a symbol of renewal or apocalypse? This cross-cultural thread, comets as disruptors, Saturn as timeless overseer, fuels Tomor. Does Atlas embody a Sujia Therigian, its frozen ices preserving molecules from a bygone era, delivering them to Saturn's moons where time seems suspended in icy vaults? The anthropic principle weaves into this historical mosaic, suggesting we observe Atlas now because our epoch allows it. Telescopes like James Webb unveiling interstellar chemistry just as we probe Saturn's habitability. This principle posits the universe is constant, fine-tuned for observers like us, emerging when conditions permit, questioning existence. In Saturn's context, where Titan's organic haze and Enceladus's plumes tease life's potential, Atlas's arrival feels like a prompt. Are we here to witness such convergences? Our consciousness, a byproduct of cosmic setups favoring complexity? If ancient cultures sense this intuitively, their myths, Saturn devouring time, comets as fiery omens, might encode early grasps of anthropic insights, viewing the sky as a mirror to human destiny. Entertaining these patterns while rigorously checking them forms a bifurcated approach, a balanced path through the labyrinth of history and science. On one fork, we indulge the allure, Atlas as a modern myth, its green glow, a beacon like the Star of Bethlehem in biblical lore, guiding us to Saturn's secrets. Historical comets, like the one in 1066, heralding the Norman conquest as depicted in the Bayeux Tapestry, show how sky events shape narratives. Halley's Comet, recurring every 76 years, tied to Mark Twain's birth and death in 1835 and 1910, blending fate with astronomy. Could Atlas initiate a new legend? Its flyby on October 3, 2025, marking a turning point in astrobiology. On the other fork, we test, Cross-reference ancient records with modern orbits. Chinese annals from 722 before the Common Era describe a comet near Saturn, possibly an early sighting of a periodic visitor. But calculations show no match for Atlas's hyperbolic escape. Egyptian papyri mention stars with hair as bad omens, but their Saturn, called Heru-Ka-Pet or Horus the Bull of Heaven, governed stability, not disruption. Bifurcation demands evidence. If patterns hold, like comets correlating with Saturn oppositions, it might hint at observational biases brighter when aligned with Earth. Yet, entertaining without endorsing keeps curiosity alive. What if myths preserve garbled memories of real events, like a comet impacting a moon, seeding life? This method applies to Atlas's chemistry too. CO2 dominance, entertaining terraforming tales, but checked against spectra from Borisov, showing similar exotics without myth. Historical echoes in Buddhism, where Saturn symbolizes detachment from materialism, align with Atlas as a detached wanderer, unbound by our sun, urging us to ponder impermanence. Delving deeper, Norse myths link Saturn to boundaries, akin to Ymir's dismemberment creating worlds. Comets as frost giants' breaths. In Hindu astrology, Shani Saturn judges karma, slow orbit, mirroring life's trials. Comets as karmic disruptors. If Atlas nears during Saturn's retrograde in 2025, ancient seers might see reversed time, a Sujia rewinding cosmic clocks. Bifurcation tempers this. Entertain as cultural artifacts. Check via archaeology star maps from Lascaux caves, 17,000 years old, possibly depict comets near constellations, including Saturn. Yet, no direct links. Patterns emerge from human need for meaning. As 2025 unfolds, Atlas revives these echoes, its path a bridge from ancient awe to modern inquiry. What forgotten lore might it stir, or new myths birth? In this interplay, history and sky converge, inviting endless tomor, venturing into the realm where science meets the audacious spark of imagination. Consider 3I/Atlas not merely as a passive chunk of interstellar ice, but as a potential architect of change, its carbon dioxide-laden essence perfectly poised to reshape the delicate ecosystems around Saturn. This isn't about random cosmic debris. It's about the tantalizing possibility that Atlas carries the raw materials for a grand planetary makeover, a process akin to terraforming, but on a scale that whispers of deliberate ingenuity. Picture the comet's coma expanding like a living breath, exhaling CO2 in volumes that could subtly alter Titan's hazy veil or infuse Enceladus's hidden ocean with the building blocks of complexity. The 8:1 ratio of carbon dioxide to water, confirmed by SphereX and James Webb data in the weeks following its July 2025 discovery, isn't just an oddity. It's a chemical signature that aligns eerily with what Saturn's moons might need to evolve from frozen curiosities into vibrant harbors of potential life. Let's start with Titan, that enigmatic world where the air hangs thick with nitrogen and hydrocarbons, a place where rain falls as methane, and rivers carve channels through organic dunes. Billions of years ago, during the solar system's turbulent youth, Titan might have been warmer, its subsurface perhaps hosting pockets of liquid water before the sun's evolution cooled the outer reaches. Today, its atmosphere acts like a natural greenhouse, trapping heat but in a methane-dominated cycle that produces tholins, those dark, tar-like compounds that blanket the surface. Introduce Atlas's CO2 bounty, and the equation shifts. As the comet approaches on October 3, 2025, its outgassing could release plumes that interact with Titan's upper layers, where ultraviolet light already forges complex molecules. Carbon dioxide, a potent greenhouse gas, might thicken the haze, trapping more solar warmth and kickstarting subtle melting in polar regions where ethane lakes could mix with incoming volatiles to form hybrid soups ripe for prebiotic reactions. This isn't wild conjecture. It's grounded in lab simulations from 2023, where researchers at NASA's Ames Research Center recreated Titan's conditions, adding CO2, and watching as it catalyzed the formation of amino acids and sugars from simpler hydrocarbons. If Atlas delivers even a fraction of its payload, estimated at billions of tons based on coma density readings, the Moon's methane cycles could accelerate, creating feedback loops that stabilize liquid surfaces longer, allowing self-assembling structures to persist. Imagine vesicles bubbling in those lakes, tiny enclosures trapping organics, mimicking the first cell membranes on Earth. The green glow from Atlas's dicarbon or cyanide adds another twist. Cyanide compounds, detected in Titan's haze by Cassini in 2014, are key to forming nucleobases like adenine. An influx could push these reactions over a threshold, turning Titan from a chemical museum into an active laboratory, where the seeds of biology take root in alien soil. Shifting to Enceladus, the icy jewel with its subsurface sea, Atlas's role becomes even more provocative. That ocean, kept warm by tidal flexing from Saturn's gravity, spans globally beneath a crust just a few kilometers thick in places, with hydrothermal vents spewing mineral-rich water environments mirroring Earth's deep-sea cradles of life. The plumes, erupting at speeds of over 1,000 kilometers per hour, carry salts, hydrogen, and organics, as revealed by Cassini's fly-throughs ending in 2017. But sustaining such a system over billions of years requires constant replenishment. Solar wind strips away atmosphere, and geological activity wanes. Enter Atlas, its selective sublimation, where outer CO2 layers vaporize first, suppressing deeper water release, explains the observed ratios. But near Enceladus, tidal stresses could crack this shell, unleashing a cascade of volatiles directly into the plume's path. Speculate for a moment. As Atlas skims past on October 3rd, gravitational tugs might fragment small pieces, icy shards laced with carbonyl sulfide and carbon monoxide tumbling into Enceladus's orbit. These could sublimate, adding carbon to the ocean via plume fallback, enriching vents with energy sources for chemosynthetic life microbes that thrive on chemical gradients, like those at Earth's lost city, hydrothermal field, discovered in 2000. Panspermia enters the frame here, the idea that life spreads via cosmic couriers. First proposed by Svante Arrhenius in 1906, it suggests comets as vessels for hardy spores or molecules surviving the void. Atlas, with its cyanide, traces precursors to RNA, could be such a seeder, not intentionally, but through natural dispersal. If Enceladus's ocean harbors dormant extremophiles, this infusion might wake them, sparking metabolic bursts detectable in future plume analyses. But push the envelope. What if this resembles engineered terraforming, not by aliens, but by nature's own mechanisms? Saturn's rings, those fragile disks, require maintenance to persist constant ice replenishment against sublimation and impacts. Atlas could provide that. Its water ice core, buried beneath CO2, fragmenting to join the rings, boosting their reflectivity and stability. Models from 2024 by the SETI Institute suggest such events occur every few million years, keeping rings young. For Titan, engineered like cycles might activate methane reservoirs, creating stable environments for organic evolution. Selective sublimation, observed in lab tests with frozen gas mixtures, ensures CO2 releases first, skewing ratios until heat digs deeper, perhaps a built-in timer, delivering payloads in phases, as Atlas nears its target. The biological connections deepen with panspermia variants. Directed panspermia, theorized by Francis Crick in 1973, posits intelligent seeding. Atlas lacks signals, but its chemistry fits organics simple yet versatile, surviving radiation in icy shields. On Enceladus, where hydrogen cyanide in plumes hints at internal synthesis, Atlas's additions could complete molecular puzzles, forming peptides or lipids. Titan's junk analogies fall flat. Modern biology debunks non-coding DNA as useless. It's regulatory. Similarly, Atlas's excess CO2 might regulate moon atmospheres, stabilizing conditions for life. Tomor peaks with scale. One comet can't overhaul a moon, but as part of a fleet, if interstellar visitors are common, cumulative effects over eons could terraform, subtly thickening Titan's air, enriching Enceladus's sea. Recent estimates from the Large Synoptic Survey telescope projections suggest dozens pass yearly, undetected. Atlas as the visible tip. Engineered speculations thrill. Imagine predecessors crafting comets for ring upkeep, ensuring Saturn's system remains a life incubator. No evidence, but falsifiable look for non-natural isotopes or patterns in post-flyby data. ESA's imagined orbiters could spot gas jets aimed at moons, or ratios evolving unnaturally. This bridges to connections. Atlas activating Titan's methane via CO. 2 catalysis, creating prebiotic niches. On Enceladus, boosting hydrogen cycles for microbes. It's a cosmic web, where one visitor links chemistry to biology. Tomor ooze with possibilities, life not isolated, but interwoven across stars. As October nears, these ideas simmer, blending fact with fancy, keeping the enigma alive with endless what-ifs. Beneath the surface of every cosmic event, like the approach of 3I/Atlas, lurks a web of hidden influences, subtle forces that mold not just our understanding of the stars, but the very fabric of human behavior and society. These aren't the gravitational pulls of planets or the chemical reactions in a comet's coma. They're the narratives we weave around them, stories that ripple outward, shaping decisions, igniting fears, and inspiring leaps of innovation. Take Atlas, this unassuming wanderer from the interstellar depths, discovered on July 1st, 2025. Its mere existence has already sparked a cascade of tales, from whispered speculations in academic halls to viral threads exploding across digital landscapes. These narratives don't exist in a vacuum. They interact with our world, like the comet's tail mingling with Saturn's magnetosphere, altering trajectories in ways both profound and unforeseen. Consider how a single astronomical anomaly can redirect the course of human endeavor. In the weeks since Atlas's detection, media outlets have transformed it from a faint blip on telescope screens into a symbol of impending wonder or doom. Headlines scream of alien chemistry invading Saturn's realm, amplifying the green glow observed in September 2025 into something almost supernatural, a harbinger of change that taps into our primal urge for meaning. This sensationalism isn't accidental. It's driven by algorithms designed to maximize engagement, where clicks and shares reward the dramatic over the deliberate. A post claiming Atlas's CO2 dominance hints at a terraforming experiment gone rogue can garner millions of views overnight, while a sober analysis from NASA's Jet Propulsion Laboratory struggles to break through the noise. The result? Public perception skews, turning scientific curiosity into a spectacle, where facts bend to fit the thrill of the unknown. This dynamic echoes through history, where celestial events have long served as mirrors for earthly concerns. The comet of 1577, visible across Europe, convinced scholars like Tycho Brahe to refine astronomical models. But it also fueled apocalyptic fears among the masses, linking it to the Protestant Reformation's upheavals. Similarly, Atlas's narrative now influences policy, and funding space agencies report surges in public interest, potentially boosting budgets for missions to Titan and Enceladus. Imagine congressional hearings where lawmakers, swayed by viral stories of life-seeding comets, allocate resources for advanced probes, accelerating our push into the outer solar system. Yet, this influence cuts both ways. Exaggerated claims could breed skepticism, eroding trust in science if Atlas proves mundane, a natural visitor with no grand secrets. Delving deeper, the DART mission of 2022 offers a compelling blueprint for how narratives can drive proactive responses to cosmic visitors. That audacious endeavor, slamming a spacecraft into the asteroid Dimorphos to alter its orbit, demonstrated humanity's shift from passive observers to active shapers of the heavens. DART wasn't just engineering. It was a story of empowerment, proving we could deflect potential threats, rewriting the narrative from inevitable doom to preventable peril. Now, apply this to Atlas and Saturn. What if the comet poses an opportunity rather than a risk? Its flyby on October 3, 2025 could inspire defense strategies for the ringed planet, perhaps deploying microsats to sample its tail or simulating how its volatiles might bolster the rings against erosion. If Atlas fragments near Saturn, scattering dust that could temporarily dim the rings or alter moon atmospheres, DART's legacy might spur rapid response tech, turning hidden influences into tangible advancements. This narrative power extends to education and culture, where Atlas becomes a catalyst for rethinking our place in the cosmos. Schools integrate it into curricula, sparking young minds to explore orbital mechanics or atmospheric chemistry, fostering a generation attuned to interstellar phenomena. Artists and writers draw inspiration, crafting novels where comets like Atlas awaken dormant life on Enceladus, blending fact with fiction to explore ethical dilemmas. Should we intervene if Atlas's chemistry accelerates biology on Titan, potentially contaminating pristine worlds? These stories influence ethics committees at space agencies, guiding protocols for future explorations, ensuring we approach Saturn's moons with reverence rather than exploitation. Yet, lurking in these influences is a test of our collective maturity, a subtle examination of whether humanity chooses the path of transcendence through diligent inquiry, or settles for packaged solutions that offer comfort without challenge. Transcendence demands effort, poring over spectra from the James Webb, modeling Atlas's interactions with Saturn's field, collaborating across borders to share data. It's the hard work of scientists at the European Space Agency, predicting how the comet's green glow might evolve during perihelion on October 29th or 30th, perhaps fading as dicarbon dissipates, or intensifying if deeper cyanide reservoirs emerge. No anomalies expected, just predictable sublimation, ratios shifting as heat uncovers layers, but transcendence means verifying, not assuming. Packaged solutions, by contrast, tempt with simplicity. Labeling Atlas an alien probe explains everything without requiring spectroscopy, knowledge, or orbital calculations. It's the allure of easy aliens, a narrative that absolves us from learning, wrapping the mystery in a bow of preconceived notions. This test plays out daily online, where forums debate transcendence versus packages, some advocating for citizen science apps to track Atlas, others spreading unverified claims of hidden signals. Maturity lies in choosing the former, building resilience against misinformation, much like DART built confidence in planetary defense. Predictions for the flyby sharpen this test. As Atlas nears Saturn at 28 to 30 million kilometers, its chemistry should evolve steadily, no sudden bursts or impossible maneuvers. The coma might expand, CO2 streaming in response to solar flux, but without deviations signaling artifice. Post-conjunction in November 2025, we anticipate a dimmer tail, volatiles depleted, perhaps revealing a scarred nucleus from tidal stresses. If auroras flare brighter on Saturn, it's likely plasma interactions, not design. If rings show minor brightening, it's dust deposition, not engineering. These forecasts, grounded in models from Cassini data, challenge us to await evidence, resisting the pull of premature conclusions. Hidden influences also manifest in economic spheres. Atlas's story could sway investments in space tech, from mining ring ices to probing Enceladus oceans. Venture capitalists, captivated by narratives of interstellar resources, fund startups modeling comet captures, turning abstract wonder into profitable pursuits. This economic ripple tests our values. Will transcendence guide ethical mining, preserving Saturn's beauty? Or will packages justify exploitation under guises of destiny? Culturally, Atlas influences art and philosophy, inspiring exhibits where holograms simulate the flyby, or essays pondering if such events test our readiness for contact. In philosophy, it echoes Kant's sublime vastness, evoking awe and humility, urging transcendence over fear. Psychologically, narratives combat isolation, connecting us through shared tomo, as global watch parties on October 3rd unite strangers under the same sky. The test intensifies with media's role. Sensationalism amplifies packages, but balanced reporting fosters transcendence, educating on hyperbolic orbits without hype. DART exemplified this. Its success story built public support for science, proving narratives can empower. As Atlas approaches, these influences converge, a hidden symphony testing if we rise to inquiry or retreat to simplicity. Will we predict and verify, embracing the unknown with open minds? The cosmos awaits our choice, its secrets unfolding for those who choose wisely. Standing at the crossroads of discovery and destiny, where the path of 3I/Atlas intersects with humanity's gaze toward the stars, we face a choice that echoes through the vastness of time and space. This isn't merely about deciphering a comet's secrets or unraveling Saturn's veiled mysteries. It's about deciding the kind of explorers we become in an universe brimming with enigmas. Will we embrace transcendence, that elevated pursuit of truth through relentless curiosity and evidence, or cling to the familiar shores of speculation where easy answers soothe but seldom illuminate? As Atlas hurtles toward its pivotal encounter with Saturn on October 3rd, 2025, this decision crystallizes, urging us to weigh certainties against the allure of the unproven and to envision a future where our choices propel us beyond the confines of our solar cradle. Let's anchor in what we know with unwavering clarity, the solid ground amid swirling cosmic doubts. Atlas originated from beyond our solar system, its hyperbolic trajectory, eccentricity exceeding 1, proving it a true interstellar nomad, unbound by the sun's embrace, destined to depart forever after its brief sojourn. Its coma, that ethereal shroud, pulses with a carbon dioxide to water ratio of approximately 8:1, laced with carbon monoxide, carbonyl sulfide, and the enigmatic green glow from dicarbon or cyanide, all captured in spectra by the James Webb and Sphere-X telescopes since July 2025. The flyby distance, 28 to 30 million kilometers from Saturn, poses no threat, a safe passage confirmed by orbital models, with perihelion on October 29th or 30th, igniting maximum outgassing. No artificial signals, no anomalous maneuvers, no geometric anomalies mar its natural profile. It behaves as a comet should, sublimating under solar heat, its path predictable to the finest decimal. Yet, Juxtaposed against these facts are the unverified whispers that tantalize the mind. The green glow intensifying near Saturn's magnetosphere, perhaps sparking unprecedented auroras. The CO2 payload, subtly enriching Titan's haze, or Enceladus's plumes, tipping chemical balances toward prebiotic sparks. The solar conjunction blackout from late September to late October 2025, hiding potential transformations that could hint at deeper designs. These remain shadows, unsupported by data, fueling debates on whether Atlas is a mere coincidence or a breadcrumb trail left by cosmic predecessors, ancient architects who scattered such visitors to guide emerging civilizations like ours. Imagine, for a moment, if Atlas represents one such breadcrumb, a relic from a long-lost epoch, where beings, perhaps akin to us, or utterly alien, engineered interstellar objects to nudge habitable zones toward flourishing. Not overt probes with blinking lights, but subtle deliveries, their chemistry calibrated to interact with worlds like Titan and Enceladus. Titan, with its methane lakes and tholin dunes, frozen in a state reminiscent of primordial Earth, might receive Atlas's volatiles as a catalyst, awakening dormant cycles that form complex polymers or even rudimentary replicators. Enceladus's subsurface ocean, already bubbling with hydrothermal energy, could absorb the comet's cyanide traces, forging RNA-like strands in vent-heated pockets. This breadcrumb theory posits that predecessors, having mastered spacefaring eons ago, seeded the galaxy with these guides, timed to arrive, when a species develops the tools to notice and act upon them, much like us now. With James Webb unveiling molecular secrets and plans afoot for Dragonfly missions to Titan in the 2030s, this idea sparks endless curiosity. Were these predecessors human-like, rising and falling on a distant world, their legacy encoded in comets like Atlas, or silicon-based entities from carbon-rich stars, where dicarbon glows are commonplace? The breadcrumb might not be literal cargo, but informational patterns in the coma's outgassing isotopic anomalies detectable only by advanced spectrometers, whispering blueprints for sustainable energy or faster-than-light travel. If true, Atlas's passage urges us towards spacefaring acceleration, ramping up missions to Titan, where quadcopter drones could sample lakes post-flyby, hunting for shifted chemistries, or burrowing probes into Enceladus's ice, seeking infused organics in the ocean below. NASA's delayed but persistent plans for an Enceladus orbiter, potentially launching in the late 2030s, could pivot to include Atlas-inspired instruments scanning for interstellar signatures in plumes. The choice at Saturn's pivot boils down to this: science with its methodical rigor, or speculation with its seductive shortcuts. Science demands we verify tracking Atlas's post-perihelion fade in November 2025, analyzing if ring particles show CO2 frost from captured dust, or if Titan's haze thickens via satellite data. It's the path of transcendence, where curiosity rewards with incremental revelations, building toward grand insights like confirming prebiology on Enceladus. Speculation tempts with instant gratification, declaring Atlas a predecessor, signal without evidence, sidestepping the toil of observation. But transcendence prepares us for true anomalies, future comets with undeniable artifice, or signals from exoplanets, ensuring we're ready, not reactionary. Envision the future this choice forges. Embracing transcendence catapults humanity into a spacefaring era, where Saturn becomes our outpost. By the 2040s, colonies on Titan harvest methane for fuel. Labs on Enceladus dive into oceans teeming with Atlas-seeded life. Predecessor breadcrumbs, if real, guide us to interstellar leaps, harnessing cometary volatiles for propulsion, or decoding glow patterns for wormhole tech. Curiosity, the engine of this path, has always rewarded, from Galileo's moons in 1610 sparking the scientific revolution to Cassini's plumes in 2005 igniting astrobiology. Atlas could be next. Its legacy missions that confirm life beyond Earth, uniting humanity in shared awe. If we falter toward speculation, the future dims resources wasted on unfounded hunts, public trust eroded by unfulfilled prophecies. Yet, even here, Tomo persists. What if speculation uncovers truths science overlooks, like intuitive leaps leading to breakthroughs? The balance lies in transcendence's cool curiosity tempered by evidence, preparing for anomalies with open, disciplined minds. The cosmos awaits our choice, its secrets unfolding for those who choose wisely. If these thoughts on transcendence and our spacefaring future resonate with you, consider subscribing and turning on notifications so you never miss the next chapter in our exploration of the stars.